So example 10.1.2, so finding the equation of the line of best fit. So we're going to go back and use the data from example 10.1.1, where we've removed the O'Doul's non-alcoholic beer, to do the following. So part A says to find the equation of the line of best fit. All right. So again, we're going to define our variables here to begin with. So in this case, we are using alcohol content is going to be our explanatory variable, and number of calories is going to be the response variable. So that means we're going to put the values of alcohol content, I put in L1, and the values of number of calories, I put into L2. But right now we're just after this equation of the line of best fit. And so if we take those coefficients, we're going to get 25.03123606 plus B, which is 26.3186076 times X. And in this case, I write too big, I filled up the line here. We need X to be between X min and X max. And so if we go back to the list of data, we will see that the smallest alcohol content was 4.15%. and the highest was 8.1. All right, so part B says to draw the scatter plot and the line of best fit on the same set of axes. You will see the scatter plot and the line of best fit drawn on the same set of axes. All right, now this assumes that you actually followed through the instructions on the first page where we did the scatter plot for that data. Make sure you go back to the very first example where we made the scatter plot initially. And again, deleting the O'Doul's beer. We're only looking at those 9 data points. We will see that in both cases we have this line of best fit. Okay, so this is our line of best fit, which we're going to discuss what qualifies it as the best fitting line here in a second. But you'll notice that there's a bunch of these points it doesn't even pass through. So there might be one in here, but even those it looks like it kind of splits right down between them. So this line of best fit doesn't even appear to touch any of the points in the data set at all. But of all the lines possible, using this criteria we're going to get into, this is what we consider the best fitting line for these 9 data points. So now if we interpret the slope and the y-intercept in the context of this data, so slope is change in y over change in x, which in this case is going to be the change in number of calories over change in alcohol content. And so if we round that off, it is about 26.32 over 1, where the units here are calories and alcohol content was a %. So the slope here tells us that for every 1% increase in alcohol content, we expect the calories, since the slope here was positive, we would expect those calories to increase by 26.32 on average. And the y-intercept here would be 0%. We plug in 0, and the output there was 25.03 calories. So again, this has no meaning with respect to this problem since we're only looking at alcoholic beers. So it makes no sense to talk about a beer with 0% alcohol. Okay, so again, the key thing on these, the relationship that we're really interested in is the relationship described by the slope.